Yes, ma'am.
Yes?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, okay. Okay, I've started the recording, so let us just start. Okay. So, in the previous class, we have just started an introduction. I'll repeat anyways. So, we were talking about our course, okay? And so, we started discussing about human-based computing, where we mentioned about the Second World War and then why this computing itself came into picture. Like there were secret code messages what were sent, and the other side, which is the opposition side, wanted to decrypt or decode the message and understand, so that they can understand the opposite teams strategies, so that they can win them. So that was the initial one of the main reason where they had some kind of computing coming into picture. Then what happened was they tried, so like a large team of people started working on complex calculations to decode the message. So we discussed how it would be, in the sense not how exactly it would be, but there would be some mechanism of encoding and there would be some mechanism of decoding also. So we try like when you get a secret code, so we try to apply some methods and see whether we are able to get some meaningful message, etc. So then what happens is that was done initially by a team of people. But then over a period of time, like it required like large number of messages were sent and it became more complex and it started requiring more manpower and time. So slowly machines came into picture where machine were made or designed to do complex calculations so that time can be reduced. And the main advantage of using machines would be it would be more accurate, like high number of more precise in the answers than us. Like if you have used calculators, of course, they give results quickly and accurately. They won't make mistakes because it is trained that way. Okay, whereas we might make mistake and we might be little slow, but then we have the thinking part. Okay, so when we need some accurate results and like quick results, we might more depend on machines. So of course there are advancement in computing, so I'm not talking about that, I'm just telling the basic things. So now, so these machines were the precursors to the modern computers. So what happens is their speed and accuracy is what gives more importance to them. But the essence of what they do is almost same as what we have done. Now we discussed about data and information. So we told data is raw, unorganized facts just listed out somewhere. We may not have any meaningful information out of it. So if you can see here, it is test, okay, not text. It's S, not X. So each student's test score is one piece of data. So if I have some students' marks, if you simply store it on a table, it doesn't make much sense. So it is data. But then if I sort it, if I filter out, etc., then it might be more meaningful. So we say it's information. So when it is unprocessed, unorganized, raw facts, we say it as data. Information means when the data is processed, organized, and presented in a given context, and it is made useful. So then we say it's information. So can you just come up with some examples of data and information? Who can try? Anyone who can just give a try? Let it be wrong. It's okay. You're just telling some example
Can you give us
of
a minute to think?
data and information. Anyone?
Can you give us a minute to think, ma'am?
Sorry.
Can you give us a minute to think of one example?
Sure. Anyone, if you have, yeah.
Product names or employees' names, any
Okay.
addresses,
Okay.
they all come under data.
Ma'am,
Prices,
marks for 6 subjects.
Yeah,
weights,
she's telling. Let her finish. Yeah, yeah.
prices, weights,
But
is all.
Can
information is like a collection of data, something like that.
sorry, Bhavya, what were you saying?
Ma'am, prices, weights, costs, these all come under data.
Okay.
Names of employees,
Mm-hmm.
yeah, that's all, ma'am. Any tax codes, yeah, these all come.
Hello. Hello,
What
madam.
about information? Wait, let her finish. Yeah, yes, Bhavya. So, what is information? Can you tell an example?
Examples of information, any documents,
Any documents?
yes, ma'am. Or the list of, or the merit list of the students in a particular class.
And
Okay.
example,
Report cards, receipts, these all come under information, ma'am, as per my knowledge.
Okay. Somebody else?
Ma'am, all the items in a store is data, like listing
Mm.
them, and organizing them in from a lower value to higher value is information.
Yeah, so you mean to say all products, say if you simply display all products and their price, it is just a data. Whereas if you sort it in with respect to the price, you say you understand which is the cheapest good and which is the costliest product, or maybe we can say maximum number of maximum number of goods sold. If that that is also there, and if we sort based on that, then it becomes like which item is sold more, because quantity of each good, how much it is sold is also there. If we sort it based on that, then that becomes information, because we get to know which is the highest sold good, etc. So if you simply display the price, sorry, the product quantity and price, it is just a data. Whereas when you sort
Yes,
it based on one of these, you say it is information. Okay, okay, okay. I don't get your name. Namrata.
yes, ma'am.
Yeah, okay.
Madam,
Anyway, yeah. Can you say your name and then tell, because I don't know you all, so it's
madam,
better.
my name is Vamsi.
Vamsi. Okay, tell Vamsi.
Madam, a story of a lesson is a data, and a model of a lesson is a information.
Yeah, kind of an analogy. So, but when we say data, it's more like facts, not story. But maybe like an analogy, we can say, if you simply say a story, we can think like a data. But when we get a moral out of it, you have some information. You can vaguely say that, but not exactly. You need to say some data where you have some facts.
Okay.
Yeah, that analogy is correct. Yes, Nitesh, you can say.
I am Nitish.
Yeah.
If data is a rock stone, then information will be a statue.
Sorry?
If data is a rock stone, then information will be statue, which comes from rock stone.
Okay. Yeah, here also maybe we can say the analogy is correct. The idea what we think is correct. If the raw rock, we can treat it like a data. But when you process it and make it to a statue, it's like an information. But exactly when you say an example for data, it should be some kind of data, as she was telling, like product and price, those kind of data. Rock is not a data, yeah.
Ma'am, I have an example.
Yeah,
ma'am,
Uh,
I think somebody
the
else also
place,
raised. You will get a chance. Yes, this is
uh,
Anirudh. Huh?
yes, ma'am.
Yeah.
The places around Bangalore
Mm.
would be data,
Mm.
and the places around Bangalore in the increasing order of their distance from Bangalore would be information.
Yeah, but you told places in the Bangalore. So now distance from where?
Like Bangalore Central, you generally take
Okay,
distance
okay.
from Majestic.
Yeah, yeah. So if you simply list,
ma'am,
sorry, say if I am making a table where I just mention the places in Bangalore and just listing out the places, or maybe it has distance also, but then we don't know what it is. But then now if you say maybe we sort it based on the distance from Central, or say distance from Majestic, something like that, then maybe you will get some information like which is close to Majestic, so which can be visited first, or maybe in increasing order, so you can know which place to visit first and then etc. So yeah, that can be treated like one is data, while the other one is information. Anindita,
Ma'am.
am I pronouncing?
Yes, ma'am. I'm Anindita. Yes, ma'am. Yes,
Yeah,
ma'am.
yeah, you can say.
Ma'am, all the books in library are data, but sorting them according to their subjects and category, we can call that information.
Yeah, correct. So when you have like 1,000 books just in your library, it is just a data. But then when we sort it based on, so all of us are now examples are all sorting. There are other things also, maybe filtering, all that is examples. It is just that since we got sorting, we are just repeating the same. Slides in a presentation, unorganized is data. Organizing them and presenting it is information, kind of. Number of votes for CM is data. Number of votes per area for the CM is info. Okay, that is fine. Timetable for our
Ma'am,
class is information.
hello, ma'am.
Okay, then what is data? Yeah. Yeah. Continue. I think Aditya wanted to say, Ravi wanted to say. One of you can start.
Yes, ma'am. I am Aditya.
Yes, Aditya, tell me.
Uh, in a newspaper, headlines is data and elaborating the headlines is information.
I think news headlines itself is actually an information.
Excuse me.
But it's
Ma'am, hello, ma'am.
Yeah, I understand why you are saying that, because
Ma'am,
but still I think headline itself is giving us some information, isn't it? So we can't say it's a data.
excuse me.
Ma'am,
Yeah.
Ma'am, is it possible that all the letters, alphabets are data and any name is an information?
Kind of. When we sort it, or when we, so simply putting some alphabets are just data. But then when you arrange it in a particular way so that you get a meaningful term out of it, you can say it's an information. A class of students is data, filtering them into toppers list, of course. Yeah, identifying the first few, all those are information, correct. Somebody is switching the video on, you can be careful. Email is data, email from Amrita is information. Okay, can we
excuse me,
say
ma'am.
hello,
like
ma'am.
that perfectly? I don't know. I'm just a second, I'm just reading the chats. There are many who have responded. Timetable for our class is information, okay. Email, okay. Everyday weather is a data. Climate, the average of weather. Yeah, you mean to say daily, like say morning to evening, if you just write down the temperature, it is data. But if I find the maximum, okay, so Vinay, I am talking about your point. So you have mentioned every day the temperature. So I can put it this way. So the temperature of Bangalore from morning 7 a.m. to evening 7 p.m. It is just a data. But then when I pick the maximum out of it, or minimum out of it, or sort it, etc., we have some information out of it, correct. Then a class of students, okay, that we said. Books are data, or textbooks are information, need not be. Surya, that's not the way we are talking. Books are still, I think, we can't say that way. Books, we have some information. Random words are data, the word forming a meaningful paragraph is an information, maybe we can say. Salary of teachers given in a random way, not random way, actually simply writing down say 1,000 teachers, 1,000 employees name, and then their salary is just data. Whereas when we have sorting them to highest to lowest, etc., we get some information. Random digits are data. Currency notes, lot of ideas coming up. Currency notes are data. Currency notes, of course, when you arrange or sort or filter or find the maximum, etc., you're doing some kind of processing, then it's information. Searching something on web is data. Okay.
Ma'am,
Yeah.
Hello, ma'am.
Data
Yeah.
is nothing but a plain fact, but if the
Yeah.
same data is processed,
Yes,
organized, and
exactly, exactly.
presented in
Correct,
given
correct.
context
Yeah, yeah, correct.
in a more
That's what we are
useful
coming
way,
to.
that is
Correct.
called information, ma'am.
Yes, yes, yes. So plain facts, what we have is data, but when we process it so that we get something meaningful out of it, then it becomes information. Searching,
Yes.
no, digits used to form a mobile number or information. Okay. It is the way you are putting it. Okay. Getting results or information. That's what I said. Like 1,000 students marks. Like say if I have now 200 students in the class, simply if I have students and their marks, it is just a data for me. But then when I have say I filter out the first few, last few, or say I find the average and then find the difference between each student's mark and the average, something like that processing is done, then it is a information. Getting results in a village, list of name is data, but when we are making a list based on income, it is an information. Okay. Any unorganized list, yeah, so any unorganized list or fact is data, but then when you process it, it becomes information. Species are data, their classification are information, maybe to some extent. The content which students entered is a data resulting Google Sheet. Google Sheet is not an information. Lakshman Sai. Google Sheet still is the data itself, but when you sort, filter, etc., based on that Google Sheet, that is when it becomes an information. Each student's homework is data. Okay, total runs. Yeah, total runs is data. Runs scored by each person is information. Kind of, not exactly. All animals are data. Different species are information. The student grade, yeah, we told about student.
Ma'am,
Humans
I'm
are
not
data.
Hello, ma'am.
Yeah, I am able to hear you, Anirudh. I'm not finishing this. Just a second. Humans are
okay, ma'am.
data, organizing them into girls. Yeah, separating out. So that is kind of filtering, Rohit. So humans, just when we have say 1,000 persons details, it is just data. But then when we separate them to say male, female, or say we organize them based on their age or height, etc., then it becomes an information. When we choose any 10 digit, it is data. But if that 10 numbers is a phone number, it's an information. Kind of. Okay. Vehicles are data, but driving them by wheels, not exactly. Yes, Anirudh, I'll be coming back to you. Groceries, arranging, yeah, arranging is always. Amrita University selected random students through AEEE, that is data, giving them particular roll number and dividing into sections.
Hello,
Amrita
ma'am.
University selected students, I think that is not data, but then students who are selected from Amrita University, I mean AEE entrance, maybe we can say it, if you just display that, it is just data. But then when you still it is not getting, yeah, maybe when you split them to
Hello,
different
ma'am.
branches, it becomes information. Yes, Anirudh, tell me.
Ma'am,
I'm
one
Noor Ahmed.
in the Excel sheet,
Mm.
if you're storing down data, isn't it already like in some kind of arranged manner? Like you either like group them with something.
Need not be, right? When you actually store the data, there won't be any organization. But then you sort or then you maybe filter out, all that you do as a processing.
No, ma'am, but like let's say you store the students and their marks,
Huh.
and like with the respective subjects. So
Yeah.
already there is some kind of sorting there, no, ma'am. So all the subjects will be in one particular column.
If I don't,
Okay.
yeah, even then there is no sorting. Like say if you have 5 subjects and there are 50 students, okay. So 50 students, 5 subjects marks simply displayed in Excel, will it be meaningful? I don't get to know any information out of it, right? But when you maybe find maximum of each subject and or maybe average of each subject and then say students who are above this, below this, etc., then there is some meaning.
Okay, ma'am.
Okay, so simply writing down the data even in Excel may not be may not be information. Actually, wonderful. There are many ideas coming in. I am not able to like fully read There are so many. Wonderful. Anyways, you are at least thinking and even listening. Somebody has raised their hand. Uh, yeah, Kamal, what is it?
Well, code is data and outcome is information.
Code is data, outcome is information because you are feeling processing it. Okay, to some extent, not exactly what we are telling when in terms of, yeah, maybe we can say not. I think that way we cannot say. It's like input and output. No, not input and output, some function and it gives an output. We cannot say it is processing, of course, but that is not a differentiation between data and information. Anyways, but you have different thoughts. It's okay. I think we've got wonderful to know all of you. You have put a lot of comments. I saw most of it. Most of it is correct. So basic ideas, I think most of you have got it right also. So like say when we have, so of course, what is our main interest is when we say data and information, we have for data, it is just some plain facts what we have. But then when you organize it in some way, when you sort it, filter it and all that, when you then you get it, then what you get is information. Okay. So I think all of you have
Hello,
made,
ma'am.
yeah,
I'm Noor Ahmed, ma'am.
yeah.
Data is based upon observations and records,
Hmm.
and the information is analysis of data.
Yes, that's what. So when you process the data, analyze the data, organize the data, you are getting some information. Okay. So thank you
Like survey
everyone
data
for,
example.
yes, yes, kind of, yeah. You get the data, but then when you analyze it or interpret it or maybe organize it, so that's what we say sort or arrange it in some order or maybe filter out some things, etc. Then some kind of processing is done, some organization is done. Then we say it is then what we get is information. So I think that is clear for most of you. All of you have come up with good ideas. So I think it's fine. So let us move on. Sorry if I have not read your messages read out loud. Most of you have. I have just gone through most. Most of you have done said it correct. One or two partially correct because some places when we say data, it should be a data itself. Okay, but anyway, I am happy that all of you, many of you have responded. Fine. So let me just continue. So we were here. So we discussed about this. Now we were talking about this. Just a second. I'll just zoom it. Yeah. So then we talked about power of computing. Then we discussed about software. I even mentioned about system software and application software. So all your operating system, if you have not heard the term, what you say, your Android, Windows, Ubuntu, Linux, all these are operating system, like the basic thing, how your system would work. So that those are like main examples for your system software. There are others also like compiler, interpreter, etc. You may not be familiar, so it's fine, you leave it. But then understand that there is something called system software and application software. So when we say application software, it is for a particular application. So when I say, for example, Word, it is for a particular application, that is to type contents, etc., isn't it? So when I say if it's an Excel, so it is to store data and then some processing can be done. So that is the purpose. So it is application software are for particular applications, whereas system softwares, so when you say WhatsApp or Facebook, they are also application software because it is for a specific use. Like so, WhatsApp can be used for communication. Facebook is a social media where we share each other's thoughts and maybe post. Then maybe we share our videos and photos, etc. But then it is used for that particular purpose only. It cannot be suddenly used for. But these days they advance in so many, like you have so many features in different applications. That is true, but still you have a particular application for that or use for that particular application. Whereas it is when it is system software, it is more related to the system functioning. So when I say operating system, you know that Android is required for your system, your phone to work well. Similarly, Windows or Ubuntu, etc., are other operating system which are system softwares which is required for our system to function. So those are also software, but that is the purpose is little different. Okay, so those terminology I'm just bringing in. Maybe we'll see at a later stage also. I'm just bringing because that software term came up. So the base of software development is computational thinking. We even mentioned this is the person who started this term. The term is coined by Janet M. Wing. Then, so computational thinking is the way to think like a computer scientist. So you don't have to think that only CSE people are computer scientists. Nothing like that. These days, everybody is involved in some kind of computer science because all are working with, say for example, these days in online classes. Many of your seniors, if you have cousins or friends, etc., studying here or maybe even other places, doing BTech third year, fourth year, etc., they may have labs online. Now, even you, actually, if you have come here physically, you may have had physical, I mean, the actual labs, hardware labs, which most of them are now would be trying in a software. Okay, so I'm not talking about CSE labs. That even though if you come here, most of it was same only that you would try in your lab here. Now you are trying in your laptop. That is the difference. But I am talking about the hardware labs. There are many labs which you used to actually do with hardware components, which now since it is online mode, you are doing it in simulators. So that way you also have some kind of programming and all that coming in picture. So all of you are ECE now. Even independent of branches, you have some kind of coding and logical thinking. That is in general. Okay, so the language used might be different for different applications. Maybe for ECE, it is a different programming language, etc. But then finally, there is a computational thinking coming into picture. Okay, so don't think that CSE is so ma'am was telling computational thinking means thinking like computer scientist. So it is like more of CSE students. No, nothing like that. All of you are having some kind of CSE in picture. So it is not about the CSE branch. It is some kind of computational concepts you would have in your branches. Okay, so that way you will all have something here and there coming up in your further semesters also. Okay, so before we solve some problem, what we do first is we first understand the problem well, and then we identify what are the different ways how we could solve it. Okay, and then how do we do this? The computational thinking allow us to do this. Okay, so what happens in computational thinking? We take a complex problem, understand what the problem is, and then develop possible solutions. Okay, then we present the solution in a way that a computer, human, or both can understand. Where I mentioned about the computers actually understand only binary. Okay, now we discussed about four cornerstones. Okay, so that is four cornerstones of computational thinking, and we even mentioned that they are like four legs of computational thinking. So one of them falls, it fails. So abstraction, decomposition, pattern recognition, algorithms, they're all coming as different chapters, but still we will just mention what is what. If you remember from previous class, can you just tell one of you can just tell me what each of these, like maybe four persons can tell. Maybe first one of you can say what is decomposition.
Ma'am.
Yeah.
Breaking down the complex problem.
Yeah. So you have a complex problem to solve and you are simplifying it, not simplifying, maybe you're breaking down to different parts so that you can solve these parts separately and then combine kind of. So if you have done programs, you would know like modules, what we talk about is actually this. But then if you don't know also, if you think of developing an application, assume that you are going to develop a university management system. Now we have something called AUMS, which you would be, I think you would have heard about AUMS in your induction program, isn't it? University management system, did they talk about?
Yes, ma'am.
Yeah.
Yes,
Oh, yeah. So that actually has different components. So it's mainly for your marks, your exam conduction and all that. Okay, so similarly, so you may have, so for example, I am asking you, like say I make a team of 5 students and I ask you to develop a university management system, a new one. So of course, university management system, you may have so many modules, so many components, like you have exam module, you have marks, and in that itself you have marks entry, you may have grade sheets, each student's grades, then subject wise marks, then you may have attendance, then so those kind of things related to your marks, etc. Then you may have students personal details, so maybe you have personal information as one particular part. So like this you may have different, like library would be there, so that can be another part. Then materials, I can upload the materials in AUMS actually, so that can be resource sharing can be another part. So similar to this, you may have some 5 6 tasks, 5 6 parts for this major problem. So you're subdividing it into these parts, and then what you would do is each of you would solve these one of these parts, and then finally combine everything and bring up that one single solution. So when you have a complex problem, this is the way you will usually do. So you break down this complex problem into simple sub problems, and then each problem would be solved. See, each small problem would be separately solved and then come up with a integrate the solutions. Okay, so that is decomposition. Now can one of you say me about abstraction?
Focusing on important
Abstraction is
information.
the process of filtering out
Focusing on important
useful
information, ignoring irrelevant
and
details.
ignoring irrelevant data.
Yes, 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 yes. I think all three, four of you told the same. So ignoring the irrelevant details and projecting out only the relevant or appropriate information. So the
only
example,
needed information.
just to remember, I told is opening the door. So when I say open the door, I'll just tell you to open the door. I won't tell you get up from your seat, move towards the door, take these many steps, turn the knob, etc. are irrelevant because it's obvious. We don't say that. So similar, that's an analogy. Don't really, I mean, don't think exactly like that, but that is how it is. Irrelevant details are ignored and only important information is explained, I mean, shown or revealed. Okay, so that is abstraction. Now, what is pattern recognition?
Recognizing
Detecting
similarities.
only similarities.
Recognizing similar problems.
Yeah. So I recognizing similar problems or identifying patterns which are similar, which is similar to this. So when we say we have a problem, like say develop a university management system, you may try to find out what are the similar existing problems or solutions. So these kind of problems were there previously. So these kind of solutions we have seen. So we will also try to bring up something like that. So when we give some questions for you in test, you also would think what kind of similar questions we have seen in class, something of that sort. So patterns. So when you see a cat, you identify it as a cat because you have seen certain similar objects and you have learned it as that pattern is already marked in your brain as cat. So something like that. So that is pattern recognition. And what is algorithm?
Developing a step-by-step solution.
Yeah,
Arranging
step
them
by
in order
step.
Set
to
of steps, solution for the
Exactly. Step
complete
by
task.
step instruction to follow to do a particular task. So that's when we mentioned about algorithm, where like say algorithm to find long division or to perform long multiplication, etc. You have certain instructions step by step to be done. So that can be told as an algorithm. Okay. We mentioned these examples, etc., like how to find prime numbers, how to do long division. So max, I think you have done already, but those algorithms are the step-by-step instructions to do that particular task. So solving a Rubik's cube, all the set of instructions how to solve, that is your algorithm when you write it. Okay, so that is then we talked about before. I think this we didn't talk about. So before computers can be used to solve a problem, the problem itself and the ways in which it could be resolved must be understood. Computational thinking is what we are, I mean, is what is helping us with it. So thinking computationally means not programming. Okay. So that's what they say. It's not even thinking like computer because you can mute yourself, all of you. So because computers don't think. Okay, so it's just binary. It is just following some instructions. So the instructions, how do we make the computer do something? That kind of a thing is um, what do we tell the computer to do? So that is our computational thinking. Okay, so that is computational thinking enables you to work out exactly what to tell the computer to do. Okay, so that is our computational thinking. So what is computational thinking and what it isn't? So conceptualizing, not programming. So we are just the concepts we are telling, not the exact program. So when we get a problem, how do we come up with a solution? What are the things to be done, etc. comes under computational thinking, but not exactly like give an input, you get an output. That may not be there. So fundamental, not rote skill. So it's a fundamental skill what we have. A way that humans, not computers think. Of course, computers not that way. What we think and what solution we may find. So those kind of things are into your computational thinking. Complements and combines mathematical and engineering skill. It is ideas basically, not what is already constructed. It is just the ideas before that. Okay, so it is just. So, for example, it is actually an interesting example. So, for example, if you agree to meet your friend somewhere, okay, you've never seen before, you would probably plan your route before you step out of your house. You might consider the routes available and which route is best. That this might be the route that is shortest, quickest, or one which go past your favorite shop. You would then follow the step by step directions to get there. So that is like, say for example, one of you're planning to meet one of your friend. So what, and assume that you don't know the exact place, like you've not gone to that place before. So what you would do is, so assume that you're going from your hostel or college, say to Majestic. So maybe you don't know, you're going for the first time. Okay, maybe many of you don't know Majestic now because you've not come to Bangalore. This example was actually usually relevant when I usually say in our normal classes. Now since you have not come, assume that you're going to some place where your friend has come and you have not gone to that place. So you usually check Google Map, etc. Like you find out the route, etc. So of course, for some, the interest would be on shortest, like I want to reach on time and I may not be able to start a little early. So I want to like in exact, like without spending more time, I should reach. So maybe we are talking about the quickest route. So usually in cities like Bangalore, it is not just the distance, it is more concerned about the traffic also. So there are roads which are very heavily which has huge traffic, which we won't choose. Even though it is very nearby, we may not go through that route because it's the traffic is so bad. So then our interest is more, if my interest to reach there is to reach quickly, that is my interest, then I may choose a route. Maybe it is little distance wise little far, I mean longer route, but then I'll reach quickly. So that is my choice. So what if my interest is to just say I want to take only a short distance, I don't want to like travel more. So I say shortest. So the distance wise, whichever route is closest, I may take that. Now maybe I am not interested in both. My interest is I want to, on the way, maybe I want to get to a sweet shop and buy something and then go. So I would have an interest to take a particular route which has that shop. So there I may not be considered bothered about, maybe I can start little early. So my interest is not in that shortest, quickest, etc. My interest is to go through that way because I want to get to a shop and buy something to my friend. So these are different possibility when I say best. So what they're saying is, always when I say best, it is not the same best. Okay, depending on your problem, you may have a best solution. So when I say I want to reach my friend's place quickly, so then maybe route A is best. If I say I want to reach where I don't want to travel more, so their distance, the shortest might be more considered. Whereas if I have a different option, there that might be taken. So the best depends on what you actually want. Okay, so when you have decided this, you finalize. I mean, you want your problem is See, now I want to make a point here. Whenever we say problem, don't think like you're. Do you have any problems? It is not that problems. Okay, so problems means there is a problem. We find a solution. So it is a task. That way you should think. Don't think a problem created kind of a thought shouldn't be there in your mind. When I say problem, it is like a task. Okay, it's a question or it's a problem which is given to you and you are finding solution. That is the idea what you should have in mind. So when we say the problem here is meeting your friend. Okay, so of course your house to his or her house, the travel is what is your problem, and then the solution would be, the best solution would be taking an appropriate route. So first you find out different possibilities of solution. So there are say multiple routes, route A, route B, route C, and you identify best based on your interest. Okay, then after that what would you do? You would have a step by step instruction to get there. So that is your, like say if you follow the map instruction, like say turn left, then right, etc. So these kind of things would be your step by step instruction. Okay, so this entire thing, okay, would be your, so the planning part is like computational thinking, and then following the direction is like your actual programming. So initially deciding what is the best possible route, what is your actual problem, what are the different possible routes, what is the best route suitable, etc. All that comes into computational thinking. And finally actually following the directions, like moving from this place to that place, that is your programming. Okay, so that is like an end part of it. Okay, so basic, what you come up with an idea is your computational thinking. They're just trying to differentiate what is computational thinking and programming. So being able to turn a complex problem into one we can easily understand is a skill that is extremely useful. So this is already there for you. When you get a complex task, of course we try to subdivide and then kind of solve it. Each complex problem would be broken down into several small decisions. So that is called decomposition. Relevant details are only focused, then it is abstraction. Knowledge of previous similar problems used, then it is pattern recognition. Step by step plan of action is your algorithm. So if you were to create your own computer game, so what kind of questions you would have in your mind? So you may think like, what are the different modules or features what you can give? So say how the user interface should look like. What are the different, like how many rewards, in which places I should be giving rewards. So these many, like so many thoughts would come. So you would maybe analyze, you will first maybe divide the problems into sub problems. Then you will try to identify similar problems which are existing and then their similar solutions. So all these things will come into your mind, and then you will finally have a step-by-step instruction. When you follow that, finally you reach your will come up with your solution. Okay. So that's it. I actually went through this same slide once again because it's a first class. I didn't want you to like have any doubt or something. But I don't think we can move on to the next chapter now. It's almost time. So our class is still 9:20 and it's 9:20. So if anything, we'll discuss. If any confusions, otherwise we'll stop. Anything you want to ask me?